Welcome back everyone. In this video we're going to discuss the characteristics of sound. So if you haven't watched my previous video on sound introduction, please make sure you watch that video first and then you can come back to this video. The link is in the description. Let's get started. We all know sound travels in the form of a wave. Now this wave is compared to the ripple formed in a pool of water when you throw a stone in it. Now, this wave has three main properties, that is frequency, speed, and amplitude. From here, the frequency and amplitude contribute or determine two main characteristics of sound, that is pitch and loudness. We will be discussing all these in the later part of the video. Before we dive into the characteristics of sound, let us take an example as shown on the left hand side of your screen, where you have a bob hung to a support using a string. Now this is called a pendulum. This is called a pendulum. Now what we are going to do is we're going to pull this bob one side and leave it. So we know that we will observe this bob to move in this motion. Now this motion is called oscillation. Keeping this example in mind, let us discuss all the characteristics of sound. The first characteristic is amplitude. Now what is amplitude? The maximum displacement of the bob from the mean position during oscillation. Okay, so this was your bob, and when it was in rest, this was your mean position. Now it was displaced in both direction, this direction and this direction. So let's say the bob reaches these two positions at its extreme, that means it doesn't go any further. Now these position are known as your extreme positions. So if you find the distance between your mean position and these extreme position, then this distance or this displacement is called your amplitude. Similarly, this is also called your amplitude. Now the SI unit of amplitude will be the same as the SI unit of displacement, so meters, denoted by m. Let us now discuss the second property, that is time period. So the definition is the time taken by the bob to complete one oscillation. Okay, so let's say this is your bob and you move it in this position. So first it moves in this position, then it comes down and goes all the way to the second extreme position, and then comes all the way back to this position. Of course it moves back, but this is said to be one oscillation, that is from the mean position to one of the extreme ends and then all the way to the second extreme end and back to the mean position. This is known as one oscillation. So the time required to make this one oscillation is known as your time period. Let us look at one more characteristic, that is frequency. Now the definition of frequency is the number of oscillations per second. That means what you can do is you can have a timer here, a watch, and you start the timer. Okay, now you count the number of oscillations made by the pendulum in 1 second. Alright, so this 1 second is very important. So the number of oscillation made in 1 second is called your frequency. So let's say the bob moves from here all the way back to here and then here. So this is one oscillation, and let's say in this 1 second only it moves back again and goes all the way here and here. So we see that in 1 second it has made 2 oscillations. So we can say that the frequency of this vibration of the bob or the oscillation is 2. Now the SI unit of frequency is hertz, denoted by Hz. So we can just write 2 hertz. Now we see that both these, they deal with one variable, that is time. Time period, time taken to make one oscillation. Frequency, number of oscillation done in 1 second, which is nothing but time. So we know that there must be a relationship between time period and frequency. Let us understand this relationship between time period and frequency with the help of an example. Now let's say that a bob oscillates or makes 2 oscillation in 1 second. That means its frequency is 2 hertz. So for one oscillation it will take half seconds. Okay, so since it oscillates twice in 1 second, that means to oscillate once it will take second. Now this is nothing but the time period. So we see this 2 is nothing but in the denominator. So we can say that frequency is equal to 1 by time period. Now if you shift T here and shift F here, then we get T is equal to 1 by F. This is the relationship between time period and frequency. Time period is equal to reciprocal of frequency or 1 by F. Frequency is equal to reciprocal of time period or 1 by T. Now since the SI unit of time period is second, then we also get for F the unit to be 1 by second or second inverse. Let's look at the fourth characteristics, that is pitch. Now to understand the characteristic pitch, we have to understand the word shrillness. Let us do that with the help of an example. Let's say a child's cry. Now when you think about a child's cry, I'm sure you are thinking of the word irritating, because the child's cry is very irritating to our ears. So this is more shrill. On the other hand, a deep voice of a person is considered to be less irritating, or it's not as irritating as a child's cry, so it will be less shrill. Let us now look at the fifth characteristic, that is loudness. Now we all know what loudness is. Like example, music at full volume is considered to be pretty loud, versus music at low volume is considered to be less loud. Now we have already said that frequency and amplitude directly determine the two main characteristics, that is pitch and loudness. So let us look at the relationship between pitch and frequency and also amplitude and loudness. For pitch and frequency, it is very simple. Higher the frequency, higher will be the pitch. Okay, so for example, 100 hertz sound, that is the 100 hertz frequency, is considered to have low pitch. Okay, these sounds are not irritating to our ears, or they don't feel sharp to our ears. On the other hand, 2000 hertz is considered to be of very high pitch and it is irritating to our ears. Now amplitude and loudness. So as pitch and frequency, higher the amplitude, higher will be the loudness. So for example, this bob. Now if this bob takes a very huge leap, that is its amplitude is very high, that means it will be very loud. Whereas if you consider this bob that doesn't displace much, or that doesn't get displaced much, then this is considered to be less loud. Let us now discuss speed of sound. Speed is nothing but how fast or how slow a wave is traveling, similar to a car's speed. So if a car or the wave is traveling very fast, we say the speed is very high, and if it is traveling very slow or slower than this, we say the speed is comparatively slower. Now we all know that the car's speed may differ due to various factors such as the road, whether the road is good or not, the car itself, whether the car is of better quality or is just a standard car, whether it's a supercar. Now all these factors that determine the speed of the car. Similarly, there are some factors that determine the speed of the sound. Let us discuss some of the factors. So the first factor is temperature. So for example, speed of the sound in air is 330 meters per second at 0 degrees Celsius, and at the same air the speed of the sound increases to 346 meter per second at room temperature. So we see as the temperature is rising, the speed of sound is also rising. The second factor is nature and physical state of the substance. Let us understand this with the help of examples. So let's say that we have two materials, an elastic band and a thread. Now when this produces a vibration, it will travel at a different speed than the vibration produced by this thread. On the other hand, for physical state, let's say we have two particles, one is in solid state and one is in liquid state. So the vibration produced by this particle and the vibration produced by this particle will travel at different speed. Let us now discuss the types of sound. So sound may be soft, it may be loud, it may be pleasant, unpleasant, it may be musical, it may be audible, that means we can hear the sound, okay, or it may be inaudible, that means we cannot hear that sound, okay. Now it is obvious that one sound may fall into more than one category. For example, music. Now music can be soft, okay, pleasant and musical and audible at the same time, okay. Similarly, a car's horn, okay, may be loud, unpleasant, audible at the same time. Let us discuss audible and inaudible sounds, okay. Now humans range of listening is within 20 hertz to 20,000 hertz. Alright, so any frequency which is between 20 hertz and 20,000 hertz, we humans can hear it. Now dogs can hear high pitched sound, means frequency which is above this. This is why even when we hear nothing outside, we hear the dogs barking, because they can hear some sound which we cannot, okay. Similarly, elephants, they can hear low pitched sounds, again below 20 hertz, which we cannot hear thanks to their big ears. Alright, so 20 hertz to 20 kilohertz is our audible range. Any sound which has below 20 hertz frequency, it is called infrasonic waves. So we can say that elephants can hear infrasonic waves. Similarly, dogs can hear ultrasonic waves. Thank you. I hope to see you in my next video. Take care everyone.